about permutations whenever the objects weren't alike, when they were all different objects. Now let's look at permutations, things that are in order, when we have objects that are like, such as the word boo. This has two letters that are the same, the O and the O. And so we want to look at how many different choices do we have in order to arrange these letters. So let's create a tree diagram. And so let's say that we select our B, or we can select the first O, or we can select the second O. If I select the B, then I have a choice of selecting the first O or the second O. Well, if I select B and then the first O, my only other option is the second O. If I select B and the second O, my only other option is the first O. If I select the first O, I can select the B, but then my only other option is the second O. If I can select the second O, but then I have to select the B. I can select the B, but then I select the first O, or I can select the first O, and then I must select the B. So if you look at this, I have 1, 2, 3, 4, 5, 6 possible outcomes. If you'll notice on this tree diagram, I don't have two choices on these last branches. It's because I only have one way to go because I've already selected those things. Okay? So, to eliminate any duplication where we have duplicate letters and things like that, we divide the number of arrangements shown by the number of ways the like objects can be rearranged. This is generalized by the following. So, whichever objects are alike, we're going to call R1, R2, whatever we're looking at. And we're going to divide those by how many times they repeat. Okay? So like in this case, we had 3 different letters. And then I had one letter that repeated. Okay? And it repeated twice. And so we would divide by that. And so technically we should only get 3 possible outcomes because if you notice this one here, OOB and OOB are the exact same thing. And then these two are technically the exact same thing. So I actually only get 3 outcomes that are completely different. I get BOO, I get OBO, or I get OOB. These are the only 3 actual outcomes that I can get that are not duplicated. And so that's what we have to be careful with whenever we do have those duplications. So let's look at the word added. We have 1, 2, 3, 4, 5 total letters. So that's going to be 5 factorial. And then the letter D is repeated 3 times. None of the other letters are repeated, so I don't have to worry about those. So that's going to be 5, 4, 3, 2, and 1. And then I have 3, 2, and 1. So those will simplify out, leaving me with a 5 and 4. So technically, I only have 20 different ways that I can arrange the letters of added that are not repeats of each other, that are not duplicates. Let's look at the word mathematics. Okay? There are a total of 11 letters. Now, the letter M is going to repeat twice. The letter A also repeats twice. The letter T is going to repeat twice. So I have 3 letters that are repeating twice out of my total 11. So I have 11 factorial over 2 factorial times a 2 factorial times a 2 factorial. So I get 11, 10, 9, 8, 7, 6, 5, 4, 3, 2, and 1, divided by 2 times 1 times 2 times 1 times 2 times 1. When I multiply all of these out and do the division, I should get 4,989,600 different ways of arranging the letters in mathematics that are not duplicates.